So today, we're going to do similar stuff, but we're going to do perimeter and area. What's perimeter? The distance around a thing. How do you get to perimeter? You add up all the sides. So if I have length and length and length and length, and add up all the lengths, I just have more length, don't I?
Yeah.
Okay. So, that's good to know. Perimeter is just another kind of length. It's the length of what you draw around an object. Okay? Knowing that, let's go back and remind ourselves about what is SF? What does SF stand for? Candy, the person who remembers, what do you think it is? That's our scale factor. And scale factor is a ratio. And so it's a over a B. It's a number over a number. Which one goes on top?
The new one.
New goes on top of old, unless I tell you otherwise. Okay? If I tell you to do, the little guy over the big guy, you do the little guy over the big guy. But if I don't say anything else, do new over old. Well, how do I pick out of these two which one's the new and which one's the old? Yes?
Well, it says triangle ABC is similar to...
Well, it says ABC is similar to DEF, but how do I know which one's new and which one's old?
Which one comes first? Yeah.
Okay, so my son Joshua was born first. Rebecca was born last. Okay, so who's older? Joshua, because he came first. Okay, so when we're doing scale factor, and I don't tell you which one's new or which one's old, in the English language we read from left to right. So which one do we get to first? ABC. Since it came first, it will be older. And the one that's on the right will be newer. Okay? That's going to be the convention we are choosing to pick new and old and new and old. Okay? Okay. So let's play like. The ratio of my sides is A over B. I don't know what the numbers are, it's just some fraction. Knowing that perimeter is also just a length, what do you think the scale factor for my perimeters is going to be?
A plus
What?
A plus B.
No.
A over B.
It's going to be A over B. It's going to be the exact same scale factor. So if I doubled all my side lengths on my shape, what's going to happen to my perimeter? It's going to be doubled. It's going to be the same ratio for the perimeter as it was for the sides. Okay? Because they're all just lengths. They are linear. They are one-dimensional. In fact, I'm going to put that up here. This is one-dimensional. This is one-dimensional. When you start getting into things with area, how many dimensions do things with area have? They're two-dimensional. Okay? And so to do those ones, I would have a dimension for like length or something, and a dimension for something about width. Well, if I wanted to find my area ratio, I would say, okay, I need the side ratio for one dimension, and the side ratio for the other dimension, which will be the same. And when I multiply them together for area, what's it going to come out to be? A squared over B squared. I just square it. That's really A over B squared. So if you want the ratio for your areas, it is not the same as the ratio for your sides. It is the square of the ratio for your sides. Do you remember how to square things?
Yes.
You times them by themselves, right? Smile and nod. By the way, What do you think would happen with volumes?
Cube.
The volume ratio would be your side ratio cubed. What's that? No, I'm just telling you a cool thing. And this is why humans cannot be the size of dinosaurs.
Oh,
Why not?
Because it's called the square cubed law. If I were to make all your legs and arms and everything and made them long as dinosaur bones, made them as long as dinosaur bones, okay? That would go by this scale factor. But your area would go up by squares and your volume would go up by cubes. And so if you're twice as tall, your weight is based on your volume. Your weight wouldn't be twice as big. It'd be 8 times more. And you'd get so heavy, your bones wouldn't be strong enough to hold up the weight, and you would crush yourself. This is why humans can, and so this law is actually a thing in biology for why you cannot be the size of a dinosaur.
oh.
I know, it's so sad. You always wanted to be the size of a T-Rex and have the cute little arms. It'd be really fun. Alas, it will not happen. So let's play around with this and see if it really works. So I want you to draw 2 similar rectangles. So draw a little guy and a big guy, and we're going to say they're similar. Which one's the old one?
One on the left.
The one on the left. And the new one will be the one on the right. And I'm going to tell you my old guy is 3 centimeters by 5 centimeters. And my new guy is 15 centimeters and 9 centimeters. So let's see if you remember from back, 6th or 7th grade. What would be the perimeter of my old guy? It's 16. 16 whats? Centimeters. What would be the area of my old guy?
15 centimeters.
Yeah, remember for a rectangle, it's base times height? So it's going to be 15 whats? Square centimeters. It's actually how many squares are inside it. Okay? And so you go to my new guy. What's its perimeter? How much?
48.
48. And what is the area?
135.
135, I'll buy that. Okay. So now let's set up all these ratios and see if these rules worked. Okay? So what is a ratio of my sides? So pick some sides to make a ratio out of.
3 and 9.
3 and 9, but which one goes on top? The new guy goes on top, so 9 over 3. And what's that equal?
15 over 5.
Oh, could I have done 15 over 5? Sure, they should all equal the same scale factor. Do they? What is my scale factor simplified?
3.
3 over 1, which is just 3. Now let's test it with perimeters. What is my, remember we do new over old. What is my new perimeter?
48.
It's 48. What's my old perimeter? What does that simplify down to? I heard 4 and 3. Yeah, 48 divided by 12 is 4. 48 divided by 16 is 3. So see how the perimeter and area were supposed to have the same ratio. Did they have the same ratio?
So far, yes.
Yes, they did. Now let's check my area ratios. What was my new area? 135. What's my old area? Simplify that. What's it simplify down to? 9 over 1, which is 9. If I squared the 3, does that give me 9?
Yes.
Well, you told me if I squared my perimeter or side ratio, it would be my area ratio. So did the rule work?
Yes.
Nice! We like that. We like it when rules do the thing they're supposed to do. So for your first example, let's play around with things a little bit. I tell you they are similar. Since they are similar, should their ratios play this game?
Yes.
Okay, so Oh, it wants the ratio of perimeters. Do I know the perimeters? Can I find the perimeters? No.
Oh, find perimeter.
Do I know if these are equilateral? So can I figure out the perimeters? No. I have no idea how big the sides are. But can I still get the ratio of the perimeters?
Yes.
How?
Side ratio.
I can find the ratio of the sides. Okay, so what is the ratio of my sides going to be here? Remember, it's new to old. So it would be 12 over 8, which simplifies to 3 halves. Well, if that's my side ratio, what's my perimeter ratio then? The exact same thing. That's it. That's what you do.
Wow.
I know, you're impressed with yourself already, and we're not even halfway through. But wait, there's more. How do I get the ratio of the areas? I take my perimeter ratio and do what with it?
Square.
I square it. So I take my 3 halves and square it to get my area ratio. And so what will that be when I square it?
That would be 9.
What's 3 squared?
9.
What's 2 squared?
4.
There's the ratio of my areas.
Wow.
Without even knowing the areas, you can find that ratio.
That's great.
Which is kind of awesome, because we're lazy, right? We're mathematicians. The less work we can do, the better. Cool. Example 2. It says the perimeter of triangle ABC is 16 feet. I'm just going to sketch me a triangle ABC. And its perimeter is 16 feet. And its area is 64 feet squared. And then it says the perimeter of triangle DEF, its perimeter is 12 feet. And it wants you to find the ratio of the areas and then also find the area of the new guy. Because remember, the one we said first was old, the one we said second is new. Thoughts? How can I find the ratio of the areas if I don't know one of the areas? Yes, ma'am?
Find the perimeter ratio and then square it.
I can find the perimeter ratio and then use it to find the area ratio. So, okay, what's my perimeter ratio? Perimeter ratio.
3 over.
It's going to be the new over the old, so it'll be 12 over 16, which is simplified how much? 3/4, I'll take that. So then my area ratio, what do I do to it? I square it. And what will you get, Will? 9/16. There's my area ratio. That was the first thing I wanted to find. But now I need to find the area of DEF. How?
Multiply 64 by...
Use this ratio. I know that for my areas, the new over the old is 9/16. Do I know my new area? No. But do I know my old area? Yes. So I can set up the proportion using that scale factor to find that new guy I didn't know. And so you'll probably want a calculator here. This will probably be on the calculator portion of your test. And you would cross multiply, and 16x is going to be something like 576 if I recall from last class. And so x comes out to be 36. What did we just find here? The area of the new guy, which is DEF. And you would get most of the points for this. Why would you not get all of them yet?
You don't get it.
I I haven't put the units. What are my units for area here? It's feet squared. Questions, problems, complaints, concerns, comments? All right, let's play with it some more. Decagons! Katie, raise your hand. How many sides in a decagon? Yes, Parker. 10, go get it. Just like 10 years in a decade. Okay. So it says the area ratio is how much?
36.
How do I write a fraction, a ratio with a colon as a fraction? Yeah?
You put the first number over the second.
First number over second. So my area ratio is 20 over 36. Now that's not simplified, but can I still use it to do the math?
Yeah.
Yes, you'll work with slightly bigger numbers, but it still works. Could I simplify it if I wanted to have smaller numbers? Yes, but let's see what we're going to do with it before I start messing with things. It says, what is the ratio of their corresponding side lengths? So I'm finding the side ratio. Okay? Now to get from my side ratio to my area ratio in similar shapes, what did I do?
Squared it.
I squared it. So how do I go backwards to get back to just the side ratio?
Square root it.
You square root it. So the side ratio is going to be the square root of this guy. So I could have simplified it first and then square rooted it, or I could square root and then simplify. I don't care what you do. Either way, are we going to leave it like this? No. How do you simplify a radical with a fraction in it? Yes?
Make it.
Don't you, what's it called? Square root the top and square root the bottom.
Square root the top, square root the bottom. Oh, what is the square root of 36? Oh, good, you don't have a radical on the bottom. Phew. But now, I've got square root of 20 on top, and of course you always check to see if it simplifies. Does it simplify? Yes, 20 is what? 4 times 5? And what is the square root of that 4?
2.
So that square root comes to the outside. What doesn't get to escape? The 5. And then the 6 is hanging out on the bottom, just vibing. And you would still not be done. Mia, what do you think's wrong with this guy?
It's not in simplified form.
Yeah, well, the radical's simplified, but now the fraction's not simplified. What's 2/6 simplify down to? And do I have to write the 1? No, since there is something else on top, I don't have to write the 1 over the 3 because you can have the invisible 1 if there's something it's attached to. And so, yeah, that's the ratio of your sides.
That is long.
Yeah, that's, but you're getting good. Is this going to take you super long to do?
Probably not.
Probably not as long if I'm not having to hold your hand for every step. I go slower so everybody can hear it, but it doesn't have to go that slow. Okay, we're almost halfway done.
Almost.
You can do this. Rectangles 1 and 2 are similar. Sketch it.
Wow.
So, but just so that, because I'm telling you, rectangle 1 is going to be smaller. Okay, I just happen to know that. What if you drew it wrong? Would it matter? No, because the numbers, you could put the numbers into a bad picture and still get it correct. But you want the pictures to match what you're doing, so. And which one will be the new and which one will be the old? The top guy, rectangle 1 here, he's the old fella. And rectangle 2 here will be the new guy. Okay? And then information, what stuff do we know? Well, here I know that the perimeter is 66 inches. And then on rectangle 2, it's 35 feet long and 20 feet wide. Okay, show the steps you would use to find the ratio of the areas and then find the area. Okay, what's the problem? Several problems that we have to deal with. What's one of them? The second rectangle is in feet. My first rectangle is in inches. When you set up a ratio, do you want there to be different units? No. You want the same units so that everything works together. So you get to choose. You can turn the inches into feet. Is this going to be a whole number of feet?
No.
Or you could change the feet into inches. Will this be a whole number of inches?
Yeah.
So let's go ahead and turn everything into inches. So 35 feet would be how many inches? Someone with a calculator. There's 12 inches for each of these 35 feet. Huh? 420 inches. What about for my height? How many inches is that going to be? 240 inches. So I'm going to focus not on using feet, but using inches so that all my units will be the same. We don't want to be messing around with different units. I have literally in real life seen how this screws up. Okay? There was a Mars lander. They were trying to land an orbiter on Mars. And two different companies were working on it. A British company and an American company. Guess what Brits use? Meters, kilometers, all that stuff. Guess what Americans use? Customary. And so when they were programming stuff, some of the programming screwed up, and when they tried to land it, the numbers were off because they had different units, and it crashed. Billions of dollars wasted because someone didn't check their units. So yes, it matters. It really, really matters. Okay, so I still need to find the area of ratios. How? Well, what's something... Do I know what the sides on this guy are?
No.
No, it could be 11 and 6, but it could be 22 and 3. So finding the lengths of the sides on my old guy is not going to be possible. But what's something I can do? Figure out something you can do.
Find the perimeter too.
I could find the perimeter of this guy, couldn't I? I could do perimeter. So what would be the perimeter if I've got 420, 422, 42, 40?
Add them all up.
Add them all up. So someone add them all up. It becomes how much?
1,320.
1,320 inches. Okay. What else can I find?
Area.
I can find my perimeter ratio. So my perimeter ratio. Which one goes on top? The 1320 because he's the new guy. And my old guy is 66. And notice, since they're both in inches, the inches cancel out. And so your ratio has no units. Ratios get to be naked a lot of the time. That's always fun. And so what is my perimeter ratio when I simplify this out? It becomes 20 over 1. So there's my perimeter ratio. Now I have a choice. Could I find my area down here and set up an area ratio?
Yes.
No.
Oh, no.
Do I know the area? Can I find the area of the top guy yet? No. Can I find the area of the bottom guy though? So let's find the area of the bottom guy. It's going to be big. You're going to need a calculator here because you've got to do 420 length times 240 height. It's a big number. Yes?
8,400 inches.
Oh, no.
1,800.
What's that?
100,000.
100,000
800.
800 inches.
My bad.
That's a lot of inches, but there's, who just caught it?
Square.
You caught it. Thank you, Ollie. Get candy for catching my mistake. Okay? That's a lot of square inches. Do you want to draw all those squares?
Yes.
Me neither. I'm just ignoring you. Okay, so can I set, I still can't set up an area ratio, can I? So how the heck am I going to find the ratio of the areas?
I found the perimeter.
Square my perimeter ratio. So my area ratio is going to be this 20 over 1 squared. And y'all should know 20 squared. You were supposed to memorize that one. It's 400. So there's my area ratio. So check off on that one. But now I have to find the area of rectangle 1.
100,000.
How am I going to do it?
100.
What? You've answered, I need new blood. How am I going to now go and find the area of this guy? I still don't know any of the side lengths. You've answered stuff, I need new blood.
Could you divide the 100,800 into 400?
How about we set up the proportion and see if I divide or multiply? I know my area ratio, it's new over old, right? So I could say the 400 over 1 should equal my new area over my mystery old area. Oh, yeah. Using the proportions like we've been using this entire unit. Okay. And so what is that going to be? Well, it's going to be 400 times A equaling 100,800. And then, oh look, yes, I do divide by 400. Always set up your proportion and work it, so you don't accidentally divide when you're supposed to multiply. Okay? So what does my area end up being once you put this in your calculator?
252
252?
inches squared. 200
And the units will be
inches squared.
inches squared. Okay? So the lessons out of this particular problem are, if you don't know what to do anything you can do. And that's a life lesson